Okay, let's go over this quiz. Here we go. The first question says, name and state the coordinates of the image of point B when triangle ABC is rotated 270 degrees counterclockwise. And there's that quick reminder there that we want to use our rules in order to do so. So when we do a problem like this, the first thing we need to look for is what it's asking for. It wants us to find the image point of B. So what we're looking for is B prime. To do that, we want to start with point B. So I'm going to look at point B, and I want to record down that point B is currently at the ordered pair -4, 7. All right. Second step is to look for the rule for the transformation it's asking for. So if I want to rotate 270 degrees counterclockwise, the rule is that x, y becomes y negative x. So I'm going to use that to find B prime. So xy, -4, 7, becomes y. So whatever was last now moves to the front. Right, y moved up front, so 7 comes to the front, and then x moves to the back and changes sign. So -4 moves to the back and it changes to a +4. So B prime is at 7, 4. All right, let's look at number 2. Number 2 asks us to reflect PQR over the x-axis. And so remember, the x-axis is the one that is horizontal. That's the x-axis. So when we reflect over that, we're going to be reflecting down. So just a little image, this triangle here reflected over is going to look something like this. It's like the x-axis is our mirror. So we want to look through all of the answer choices and see which one looks like it has been reflected over the x-axis. And that would be this first one here, because we can tell that if we tilt our head sideways, it looks like it's symmetrical across the x-axis. All right, let's look at number 3. Number 3 says that quadrilateral ABCD was reflected across 2 parallel lines that are 10 centimeters apart. What is the distance between points D and D double prime? So it's just saying if I were to reflect twice over 2 parallel lines, how far have I really moved from the start to the very end? If you remember, we always take the distance between the parallel lines and just double it to find the total distance we moved. So the answer here is 20 centimeters. All right, what single isometry would be equivalent to reflecting triangle ABC over line N, then reflecting over line M? So I'm doing a double reflection over intersecting lines. When you reflect over intersecting lines, it is the same as a rotation. So here we are rotating, but how far? Again, very similar to that last problem, we take the degrees between the 2 angles, so 42, and we double. When we double that, we get 84. So it is a rotation 84 degrees counterclockwise about point E. All right, question number 5, describe the transformation shown. Well, remember, one of the best tools is to connect all of those lines in the old and new image. And let's see if I can actually just move this over here. Look at that. And so if I connect the lines and they are parallel and congruent, then it's a translation. If the lines are just parallel, then it is a rotation. And if they are messy, if they're just parallel, it's a reflection. And then if they are messy, it is a rotation. So as I connect all these corresponding lines, that makes one big mess. And so that tells me that this is a rotation. Okay, but how much have we actually rotated? So let's look at this picture here. We start from the pre-image and we go to the image. How much have we turned? So one of the best ways to do this is to look at 2 points and compare them. So point C here is at 3, 2, and C prime is at negative 2, 3. So how do we go from 3, 2 to negative 2, 3? All right, so notice the 3 that was X has now moved to the back, and Y, the 2, has moved to the front and changed signs. So now we just want to look at our rules. Which rule says that XY becomes negative YX? And that would be 90 degrees counterclockwise. And so the answer here is a rotation 90 degrees counterclockwise about the origin. All right, let's look at question number 6. What type of a transformation is this one? This transformation looks like a reflection. If you kind of tilt your head sideways, you might notice how both sides are symmetrical across the x-axis. So this is a reflection across the x-axis. Though again, we can still try to compare points. So if I were to look at 2 points, let's say H and H prime. I notice that point H is at 5, 2, and H prime is at 5, negative 2. So how do I go from 5, 2 to 5, negative 2? Well, X stayed in the front, and Y moved to the back and changed signs. So when I look at my rules graphic organizer, I'm looking for the rule that says XY becomes X negative Y. And that is the rule for reflection across the x-axis. All right, number 7 here. Quadrilateral QRST with vertices Q, R, S, and T listed as they are there is translated using the rule XY becomes X plus 4, Y minus 6. So what do we do here? This is a translation. Remember, translation is where you add or subtract to the X's and Y's in order to move them up, down, left, right. But all I have to do, if I want to find the coordinates of R prime, that tells me that I need to start with R because R and R prime are corresponding. And so I'm going to start with R, which is at 3, 5. And I'm going to add 4 to X and subtract 6 from Y. So now this becomes 3 plus 4 and 5 minus 6. And now I'm just going to simplify that. 3 plus 4 is 7. 5 minus 6 is negative 1. 7, negative 1 is the answer there. All right, let's go to the next page. So the next page is that second grade that you're going to get for this test. And so the first one says, describe the transformation that is shown on the graph. This K prime, L prime, J prime, N prime, M prime, and then K, L, J, N, M. This one actually belongs on that first page, sorry. The next quiz starts right below. What is the transformation here? How has this changed? And I'm going to move this over here and then edit it. Let's see. There we go. All right, to find the transformation, we are going to first look at the image. What does it look like? It looks to me like it has just shifted, not reflected, not rotated. It has the same shape in the same direction on all sides. To check that, I'm going to pick 2 points. I'm going to pick K prime and K. And I'm going to count the distance between them. So to go from K to K prime, I go left 1, 2, 3, 4, 5, 6, 7. So left 7. And then I go 1, 2, down 2. So left 7, down 2. Let's check another set of points and see if it's the same rule. If it is, then we've confirmed this is a translation. So 1, 2, 3, 4, 5, 6, 7 left. And then down 2, does that get me to J prime? It sure does. So we've confirmed that this translation is left 7, down 2. All right, now on to the second one. It says, if B prime are connected by a segment and the points D prime are connected by a segment, what is the relationship between the two segments? So we could actually connect them and see what we think that they look like. So let's see, B prime is here and D prime is here. These two segments do not intersect each other. So we know that they must be then parallel, but they also look to be about the same size. How can we tell for sure? We could connect the other ones, C prime, A prime, and notice that this is a translation, and we know for sure that the translation has segments that are parallel and congruent. So that's our answer for number 9. Number 10, how many lines of symmetry does a rectangle have? As we go to draw them, remember lines of symmetry are like a mirror line where the image is mirrored across it. So I'm looking at the rectangle. I'm just going to draw my own rectangle over here. If I had a rectangle, where would it have lines of symmetry? So a line of symmetry, the first one would be right down the center here, because I could fold on that line and it would land on itself. You can always think of a piece of paper when we think about rectangles. And I have another one horizontally as well. Now, the rectangle does not have any more than this. We cannot go diagonal because the rectangle does not have all congruent sides. So the answer here is just 2. Does the regular octagon below have rotational symmetry? If so, what are its angles of symmetry? So we notice that this is a regular octagon, and we learned that regular polygons always have symmetry, and their symmetry is related to the number of sides that they have. So an octagon has 8 sides, therefore it has 8-fold symmetry. In order to find the angles of symmetry, we use this number. We take 360, because that's a full circle, and we divide it by the number of sides that this shape has. So when I do that, 360 divided by 8, I get 45. So the answer, it's got to be the one that starts with 45, but if you're curious, how do we find the rest of those angles? We just keep adding 45. So 45 plus 45 is 90, plus another 45 is 135, plus another is 180, plus another is 225, another is 270, and another 315, and last 360. All right, number 12 says define segment. What is the definition of a segment? Well, a segment, without looking at the answer choices, I know looks like this. It's like a piece of a whole line. It has 2 endpoints. So the definition here that best describes a segment is number 2, a part of a line with 2 distinct endpoints. All right. What is the best definition for a perpendicular bisector? Remember, the line of reflection is an example of a perpendicular bisector. And that does 2 things. It is 1, perpendicular to a line, but then 2, it bisects the line into 2 congruent pieces. So The best definition is a line that divides a segment into two congruent pieces, forming a right angle at the point of intersection, because it is the bisector by dividing and it is perpendicular by creating that right angle. All right, 14, select the best definition of parallel lines. Parallel lines are two lines that never intersect. So lines that lie on the same plane and never intersect. All right, let's look at question 15. LK, that line in the middle, is the blank of II prime. Now, I know that LK is the line of reflection for this transformation, but I am comparing LK specifically to II prime. Because it's the line of reflection, we know, as I had just said, that the line of reflection is always the perpendicular bisector of the line segments that connect corresponding pieces. So this one must be the perpendicular bisector. And there we go.